Hey, and welcome to the first lecture of our second unit in college algebra. We are talking about linear equations today and how to solve a statement that has a variable and an equal sign. Okay. The learning objectives for 2.1 are that we will be able to solve linear equations using properties of equality, combine like terms in order to simplify them, and not be deterred even if they contain fractions or decimals. Sometimes your answer will just be no solution or infinite solutions. So, for example, if you had no solution would be x plus 1 equals x minus 2. Or x plus 1 equals x plus 2, even simpler, okay? There is no number that I can substitute for x that will give me a solution where 1 equals 2, where this side equals this side. For example, if I put in 0 for x, 0 plus 1 is 1. But then I have to put in 0 for this side. 0 plus 2 is 2. And we would have to say 1 equals 2, which is not true. So that's what we mean by no solution. It's just an equation that's written in a way where no matter what number you put in there, if we put in the number 1, 1 plus 1 is not going to equal 1 plus 2, right? Negative 5 plus 1 is not going to equal negative 5 plus 2. There's no solution, okay? And then infinite solutions is another answer that you might see that just means there's no number that x needs to be. But if I just write x plus 1 and instead of saying is equal to x plus 2, x plus 1 is equal to x plus 1. No matter what x I put in there, that will always be true. You could put in 100. 100 plus 1 will always be equal to 100 plus 1. Good? That's what we mean by infinite solutions, and then this would be no solution. All right, so those are our learning objectives. What is a linear equation? An equation, so in this class, we have already talked about equations and expressions. An expression has the letters and the numbers and the operation signs like plus, add, subtract, multiply, divide. An expression doesn't have an equal sign. An equation, think equals, okay? An equation is a statement that has two expressions and an equal sign, okay? So it's saying, if it was written out in English instead of written out as math, it's saying this expression and the second expression have equal value. Good. Solving algebraic equations, in one variable here just means one letter. I will only have x's, I will only have r's, I will only have y's, for example, involves finding a value for the variable that makes the equation true. To solve a linear equation, clear grouping symbols, that would be parentheses, that would be brackets. You could try clearing absolute value bars. You try clearing radicals. And then use inverse operations to isolate the variable to one side by undoing. So inverse operations, the word inverse in this case in math just means opposite, right? So the inverse of adding 5 is to subtract 5, right? The inverse of multiplying by 5 would be to take that same term and divide it by 5, which you can also write like this, or like this, I guess. Excuse me. These are inverses. If, now I'm going to start introducing an x. I should have put it, so x plus 5, the inverse of that would be minus 5. X times 5, the inverse of that would be divided by 5. Now, if I take a number and square it, the inverse of that is to take the square root of it. The third root, raising it to the third power, the inverse of that would be taking the third root. This is not super important. I just want to get you comfortable with radicals, okay? So the opposite of this is this. The opposite of this is this. The important thing to know about inverse operations is that you can use them to solve equations, okay? If right here, I have x plus 1, and I want x to be alone so that it's just x equals, so I find the value of x. It's being added to 1, so now I'm going to subtract it from 1. Anything you do to one side of the equal sign must be done to the other side of the equal sign. So I'm going to subtract 1 here. I'll subtract 1 on this side because this is the equal sign wall. Now that plus 1 minus 1, they are canceled. That's why we did the inverse, and we get x equals x. Okay? Anything done to one side must be done to the other side. Oh, okay, sorry. And so you're doing inverse operations, and you want to think about it. Remember PEMDAS, where we did parentheses, exponents, then we multiplied or divided, and then we added or subtracted? Because we're doing the opposite in order to find the value of x, you're doing them in reverse. So the first thing you want to do, you're doing, because you're finding x, what you're thinking is, I'm describing x. Here, x is being multiplied by 5. So I want to do the opposite of that. So you're going to do the reverse of PEMDAS, okay? You add or subtract first, and then you multiply and divide. You only multiply and divide after you add and subtract, even though that's the opposite direction of PEMDAS, okay? Let's begin. So again, remember, you are solving for x. You want to find x. There should be one number that I can put in here, and it will make this equation true. So that's an expression, but because it has an equal sign, it's an equation, okay? Think of x as just a number we don't know yet. So we have a number, subtract 4 from that number, and I will get 7, right? And if you just think about it, because we were all familiar enough with the number 7 and the number 4, we can probably figure out what that is. If somebody came up to you, said, I have a number, I take 4 away, I get 7, you could tell them what number they had, right? But they're going to get more complicated, so we're just going to do it mathematically, okay? The only operation being done to x is 4 is being subtracted from it. So I want to think, what is the inverse of subtracting 4 so that I can isolate x? In the end, I just want x to be equal something over here, okay? 4 is being subtracted, so I'm going to add 4. Anything I do to one side of the equal sign, I have to do to the other side of the equal sign, right? Because if I have x, let's not even use letters, let's use numbers. If I have 5 times 2 plus 1 equals 11, right? That's true, because we multiply, excuse me, before we add, 5 times 2 is 10, 10 plus 1 is 11. So I know 11 is equal to 11. This is just a more spread out 11. But if I said, okay, I want to solve for 5, right? If I take away the 1, and I don't take away the 1 on this side, then I just have 5 times 2 is 11. It's no longer true. So the reason we need to do it to both sides, whatever we do, is to what is called maintain equality. Subtract 1 from this side, subtract 1 from this side, 5 times 2 is now 10. 11 times 1 is now 10. Or, sorry, 5 times 2 is still 10. Either way, you're maintaining equality. It's still true. You can't have an equal sign and not have the two sides be equal. That is why we would have no solution, right? Okay, so anything you do to one side, make sure you do the exact same thing to the other side. Here I have x. I put the plus 4 right under the minus 4 so that I can cancel them. They are inverses. If you have a negative 4 and you add 4, you just have a 0, right? So it's not x plus 0, or sorry, it's not x times 0, it's just x plus 0, so I don't even need to write anything there. I can just say it's gone. X on this side equals 7 and 4 is 11. Good? So we just say x is 11. Don't be scared if there are decimals, okay? I would recommend using your calculator. If you are ever without a calculator and you don't know what to do, line up the decimal points, okay? So negative 3.2 minus 6.6, how you would line that up is negative 3.2 minus 6.6 and subtract, okay? Negative 3.2 minus 6.6, negative 9.8 equals y minus 1.2. I combined these because they're like terms, right? Neither of them had the letter y connected to them. It was easy to combine them. And I'm solving for y. I'm isolating y, so I just want just y on this side. Everything else is going to come over here, so I might as well make it one term if possible. Good? Again, we're subtracting, so I'm going to do the opposite of subtracting 1.2, so that means I'm going to add 1.2, add 1.2. Y is negative 9.8 plus 1.2. Negative 8.6. Good? And, sorry, check your solution, forgot that part. Negative 8.6, I think that's my answer, so I'm going to write it right here, negative 8.6. And if I take negative 8.6, put it in minus 1.2, I get negative 9.8. Again, I'll just add these just to be safe. Negative 3.2 minus 6.6, negative 9.8. So both sides of my equal sign are negative 9.8. So I feel I have checked it. Here I got 11. 11 minus 4 is 7. I feel that that is true. Or I can show that that is true. Okay, here we go. Just like negative 3.2 and negative 6.6 are like terms, we're going to combine like terms down here as well. It's important that you don't combine like terms across the equal sign. Just think of that as a brick wall, okay? That's why we have to do special things to either side of the wall. You cannot just say it's negative 1.2 minus 3.2 minus 6.6, okay? We can combine 8 minus 3 and get 5, that's okay. We can't combine 8 and negative 3, okay? Over here, so that 8 minus 3 becomes 5. Over here we have 6x minus 5x. When you're working with a number in front of the letter, don't worry about the letters, just call it 6 minus 5, okay? Combine the letters. A 6 and a negative 5 is just a 1, so 6x minus 5x becomes 1x, and then we have that 8, okay? The equal sign just comes straight down. Now I've simplified it to x plus 8 equals 5. I'm going to do the opposite of adding 8, which is subtract 8, because I want my x alone. That is nothing, right? Just like this was nothing, so I'm not going to say x plus 0, I'm just going to say x. X equals 5 minus 8. That was confusing because I underlined the 5, so it looks like 5 divided by negative 8, but it's 5 minus 8, negative 3. So x is negative 3. When it gets more complicated, it's harder to tell whether or not you have the right answer just by looking back to this. but you can plug it in, substitute it in. 6 times negative 3 plus 8 minus 5 times negative 3. I want that to equal 8 minus 3. Good. 6 times a negative 3. And remember, this is why I use parentheses, because I don't want to think that I'm writing 6 minus 3 or 63. All right, I'm writing 6 times negative 3, which is a negative 18, plus 8 minus 5 times a negative 3, or you can say negative 5 times negative 3 is a positive 15, or minus 5 times negative 3, which is a negative 15. So minus negative 15 or plus 15, right? And we know that x minus 3 is 5 because we already did it up here. Now I would just add them 2 by 2. Negative 18 plus 8. 18 minus 8 is just 10, right? But the 18 was negative, so it's a negative 10. Minus a negative becomes a plus 15 equals 5. Negative 10 plus 15, 5. 5 equals 5. Good. So we've checked all our answers. You're not typing in 5 equals 5. You're typing in x equals negative 3 for your final answer. Good? Okay. 4p minus 11 minus p equals 2 plus 2p minus 20. So look for your like terms, okay? Those are like terms, and then on the other side, you can combine 2 and negative 20. So go ahead, pause the video, see if you can do it by yourself, and if you get the same answer as me. Good? All right. 4p minus p, which is the same as 1p. 4p minus 1p is 3p. Bring down that negative 11. 2 minus 20 is a negative 18 plus 2p. Now I have p's on both sides. You can decide. Do you want, remember this is a wall, do you want to move this p over, these 2 over here, or these 3 over here? What I like as a math teacher is to always have a positive number with my variable, but I also like to have my variable on the left. So there's no wrong answer, it's just whatever looks easier. I tend to go with keeping it positive more than keeping it to the left. So I'm gonna move this 2p. I still have to do the inverse. So we're adding 2p, so to do the inverse, we still have to subtract 2p, okay? Now those are gone. I still have negative 18 alone on this side. I still have the negative 11 over here, and 3p minus 2p is just p. So I have p minus 11 equals negative 18. Last step is going to be add 11. Add 11 because I want p to be by itself. P equals negative 18 plus 11. Don't hesitate to use your calculator, okay? Negative 18 plus 11, or 18 minus 11, is 7, but the 18, the bigger number, is negative, so it's a negative 7. The difference between 18 and 11 is 7. The 18 is a negative, so it's a negative 7. Go ahead, put that back. 4 times 7 minus 11 minus 7 should equal 2 times 7 minus 20. Good? 4 times 7 minus 11 minus 7, we get 10. Over here we get 2 times 7. Oh, plus 2, sorry. 2 plus 2. And it's a negative 7. Ooh, I did not write that well at all. At least I caught myself somehow. All right. 4 times negative 7 minus 11 minus 7. 4 times negative 7 is negative 20 minus 11 minus 7. Negative 46. 2 plus 2 times negative 7 is negative 12 minus 20, negative 32. Well, it's still not working. Oh my gosh, checking my answer. I'm failing at. All right. 4 times negative 7. So maybe don't check your answer because I make so many mistakes checking my answer. All right. 4p becomes 4 times negative 7. Negative 11 remains negative 11, or minus 11 remains negative 11. Negative 1p becomes negative, or minus negative 7. So I should be adding that last 7. Equals 2 plus 2 times negative 7 minus 20. Let's cross our fingers. Hope I got it this time. 4 times negative 7. Negative 28. Minus 11. Minus a negative is going to be a positive, so I'm going to call that plus 7. 2 plus 2 times negative 7 is a negative 14, right? Minus 20. Negative 28 minus 11 plus 7. Negative 32. It's voting okay. If this side's still the same. 2 minus 14, right? Because it's plus a negative 14 minus 20. Negative 32. Notice that this minus sign only applies to the 14, right? It was plus 2 times negative 7, so that became negative 14 minus 20. So when I'm putting it all in, I'm not saying 2 minus 14 minus 20. If I had put like a parentheses in, it would have given me a different answer. So just always respect the parentheses. You're not know when you're distributing a negative and when you're not. Okay. I think the lesson here is take this as seriously as solving for x, because that took me at least 3 tries. I don't want to think about how long it actually took. Okay, remember when we were summarizing what to do? We said to solve linear equations, clear grouping symbols and fractions. Okay, that's what we're doing first, is we're clearing grouping symbols. For this one, we have 3 times the quantity, 3x minus 5 equals 10x. To clear this grouping symbol, I'm going to distribute the 3. The 3 is going to be multiplied by the 3x and multiplied by the negative 5. 3 times 3 is 9x. 3 times a negative 5 is a negative 15. The other side stays the same, right? Again, you decide whether you want to move the 9x over here or the 10x over here. I'm going to move the 9x because I like my x's to be positive. So that cancels. You have a negative 15 equals 10 minus 9 is x. Oh, that was fast. Let's see if I can do the hard part. 3 times negative 15 minus 5. Barely, equals 10 times negative 15. Good. 10 times a negative 15, think about that, try to do it in your head. 10 times a negative 15 is negative 150. Here I have 3x is going to be 3 times negative 15. Right? That's the 3x minus 5, negative 50, and then we're going to multiply it by 3 again, by this outside 3, and we get negative 150 is equal to negative 150. This is a short one, so it might be a good example to show you how it's okay to go the other way. So that was 9x minus 15 equals 10x. What if I wanted to move the 10x instead? So it's a positive 10x. I'm going to move by subtracting 10x from both sides. So now it's 9x minus 10x. I get a negative 1x, which I'm just going to write as a negative x, minus 15 equals 10x minus 10x is 0. When there's nothing else, here you can just put the 0 down because there's nothing on this side. If there's nothing, nothing is written with 0, right? Negative x minus 15. I'm going to add 15 to isolate the x. Negative x equals a positive 15, but I can't stop with a negative x, okay? What do I do to make a negative number positive? Negative 1 is negative 1, but if I multiply it or divide it by a -1, I change the sign. Okay, so whatever makes the most sense to you, multiply it or divide it by -1. Anything you do to that side, do it to the other side, okay? That -1 times a -x, negative times a negative makes a positive, so I've changed it from a -x to a positive x, but I have to do the same thing on this side. A +15 times a -1 is a -15. So either way, you get the same answer. Oh, it's the hard one. The hard one remains. Trying to cheat. Finish early. So that third example was 3 times the quantity y plus 3 over 5 equals 2y plus 6. 1 second. Okay, we already looked at it once, but remember, first thing, clear grouping symbols and fractions. In this case, I'm going to clear the grouping symbol first, and then I'm going to clear the fraction. But since a fraction is itself a grouping symbol, sometimes it doesn't matter, okay? You can start with the 5 or you can start with the 3. I'm going to start with the 3 because it is the thing that adds the most. That would be the step that would simplify it the quickest, right? That would get rid of these parentheses. Instead of having 3 terms and 2 operations, I would have 2 terms and 1 operation. It just seems like it will make it look the most clear. 3 is going to be distributed to y. 3 times y is just 3y. 3 is then distributed to a positive 3, so it's 3y. 3 times 3 is 9, plus 9. 5 stays the same. 2y plus 6. If there were any like terms to combine over here, you can combine like terms. As long as things are very separate from each other, you can do 2 steps at once. Just so long as they're not interfering with each other, right? Now, the next step is to clear a fraction. If you have, let me think about this 1 second. Right, if you have, for example, so this is not related to this, it's just an example for what we're doing. If you have 1/5 plus 1/5 equals 2/5, okay? This is true, but maybe I'm very wary of fractions. I don't like working with fractions. Anytime you want to get rid of fractions, you have a numerator on top and you have a denominator on the bottom, right? What you can do if you want to get rid of this fraction is multiply everything in the equation by the denominator, okay? So 1/5, the denominator is 5. I'm going to multiply it by 5. I have to do everything multiplied by 5. Okay, both sides multiplied by 5. It's probably better to write it like this. We're going to multiply this side by 5. And then we're going to multiply this side by 5. And this side is 1/5 plus 1/5. And this side is 2/5. Okay? Then I'm going to distribute out that 5. So then I'm going to write it like this. Because if this was just adding, right? If instead of multiplying we were adding plus 5, if I wrote it here and I wrote it here, that would actually be adding 10 to this side, right? But with multiplication, we do spread it to each one, like parentheses. With addition, we don't. So it's nice to write it like this to make sure you know I'm doing it to everything. But if that was just addition or subtraction, that doesn't mean that this gets 5 taken away and this gets 5 taken away. We're just multiplying, but we're multiplying by everything. So that's 5 times 1/5 plus 5 times 1/5 equals 5 times 2/5. So I wanted to get rid of these fractions because I don't like fractions. It's easier without them. And when you multiply a number that's being divided by 5, the bottom goes away. 5 times 1/5. Oops. 5 times 1/5 is 1. Good? So if I have the same term in the top of my fraction and the bottom of my fraction, they cancel out. And what I'm left with is 1 plus 1 is 2. It's true, right? So that's what we're doing. If you ever see a fraction and you don't like fractions, perfect. Even if there's only one, that's better. That's better if there's only one. You can still multiply things that aren't fractions by that fraction, all right? So let's see it. I don't want this denominator. This denominator happens to be a 5, so I'm going to multiply this side by 5. Anything I do to this side, I have to do to all of this side. So that's 2y plus 6 being multiplied by 5. Good? Okay, what does that become? 5 times 3y plus 9 over 5 means that's gone. That's no longer a fraction, and I can just take the numerator of it. 3y plus 9 is 2y plus 6 times 5. So just like we've been distributing monomials to binomials, we're taking that 5 and we're treating it like a multiplication problem. 5 times 2y is, 5 times 2 is 10, so 5 times 2y is 10y. 5 times 6 is 30. Good, your fraction's gone. Yeah, and even if we had, so let's go back before we solve this, because you already know how to solve it anyway after this point. If we had ignored these grouping symbols and dealt with the 5 first, and said, oh, I'm so scared of fractions, I need it to go away right now, you can. Good. That gets rid of that, and you can just write it as 3 times y plus 3 equals, same thing, 5 times 2y is 10y, 5 times 6 is 30. And then say 3 times y is 3y, 3 times 3 is 9. Either way, we got to the same step. Good. It's not finished yet, but it will be finished the same way we've been finishing everything else. 3y plus 9, 10y plus 30. Right now, I want you to look at, or what I would do is I would look at my y's and say, how am I going to get the positive y, right? Because when I chose to go the positive route, it was a one step, right? When I chose to move this one over and make the x negative, then I had to, so this was one step, 1, done. This was 1 step, 2 steps, 3 steps. Okay, that's why I like keeping them positive. So 10y minus, so if I take the 3 and move it, 10 minus 3 is going to give me a positive number. If I take the 10 and move it, 3y minus 10y is not going to give me a positive, right? That's going to give me a negative. So I would like to move the 3y over here, even though it'll be kind of like looking not the way you usually see it in a math book. So I'm going to say minus 3y because I don't want this 3y over here. I want the 10y. Focus on the bigger y. 3y minus 3y cancels. I still have a plus 9. 10y minus 3, 7y, plus 30. Obviously, you don't need that plus 9. You can just write a 9. Now, we need to move the 30, right? We can't move the 9 over. That's not going to help us. Move the 30. You want y alone. We need to add and subtract before we multiply and divide, of course. If you divide it all by 7, like you can, right? You're just adding more fractions back in. So no. It's much easier to move the 30 over before we divide by anything, okay? So it's being added to y. We're going to subtract it from y. Anything we do to this side of the equal sign, we have to do to the other side. 30 minus 30 leaves us with 7y. 9 minus 30, don't hesitate to use your calculator. 30 minus 9 or 9 minus 30. Either way, we get 21. The 30 is negative, the bigger number is negative, so it's going to be a negative 21. And now, hopefully, you have a nice division problem, right? It's being, the number we don't know is being multiplied by 7. To get rid of being multiplied by 7, the opposite of is divide by 7. Negative 21 divided by positive 7 is a negative 3. Okay, and you want to check your answer because that was a lot of work we did. So you want to make sure you got the right answer. The original equation was that 3 times the quantity y plus 3, gosh, it's going to be the death of me, over 5 equals 2 times y plus 6. So I'm going to substitute that in. 3 times 3 plus 3 over 5 equals 2 times 3 plus 6. Negative 3. Okay. You are welcome to distribute the 3 or combine the 3s. But combining the 3s looks easier, right? Yeah. So now it's 3 times negative 3 plus 3 is 0. 3 times 0 divided by 5 is 2 times negative 3 is negative 6 plus 6. 3 times 0, anything multiplied by 0 is 0. 0 divided by 5 is negative 6 plus 6 is also 0. 0 divided by 5 is 0. Good? That doesn't mean there were infinite solutions. It just so happens that final answer is 0. So there's only one answer, and it's that y is equal to negative 3. But we checked it. We got the same number on both sides, so it's okay. However, sometimes, like I showed you in that first example, or sorry, on that first slide, there are equations with no solutions. The variables eliminate and your remaining equation is false. And then there are infinite solutions where you have an equation, your variables eliminate, and your remaining equation is a true statement. All right, what was the one I made up? I said an infinite solution is that x plus 1 is equal to x plus 1, right? And I said a no solution was x plus 1 is equal to x plus 2. I tried to solve it, right? We said x plus 1 is equal to x plus 1. We can subtract 1 from each side to solve for x. Just, I'm going to pick this x. I'm going to move the 1 before I move the x. Subtract 1 from that side, I get x. Subtract 1 from this side, I get x. X equals x. That's true. And it doesn't matter what other numbers there are. X is going to equal x. No matter what number you put in for x, it's going to be infinite, okay? Or you could choose to say, well, that was weird. I moved the 1s first and I got x equals x, right? Now I'm going to move the x's first. I'll subtract x from this side and subtract x from this side. And I get 1 equals 1. That is true, okay? So you can take out all the variables and the equation is still true. What if I had x equals x and I took it one further and I subtracted x from this side and subtracted x from this side? X minus x is 0, x minus x is 0. Good. What if I had x equals x and I said, let's divide by x, divide by x? That just means 1 equals 1, okay? So, because a number divided by itself is always equal to 1. So no matter how you end it, even if they all look different, 1 is equal to 1, that's always true. X is equal to x, that's always true. 0 is equal to 0, that's always true. And 1 is equal to 1, that's always true. So you won't, by the end of it, you won't have any variables and your equation is a true statement. Or you have variables, but it's very clear that no matter what variable you put in, it will always be true. X will always equal x. No solution. X plus 1 equals x plus 2. I'm going to move the 1 that's being added, so I'm going to subtract. Now I have x equals x plus 2 minus 1 is 1. Move the x's over here, subtract x, subtract x. X minus x cancels, right? They fall out. They fall out. There's nothing over here, so I have to write a 0. 0 equals 1. That's a no solution because your remaining equation is false. That cannot be true, okay? No matter how you solve it, even if you said x plus 1 equals x plus 2, and I'm going to move my x. subtract x, 1 equals 2. That's still not true. Okay, so you'll eventually lose all your x's and you'll be left with either it's always something that's always true or something that is never true. If it's never true, it's no solution. Okay. If it's always true, there are infinite solutions. So let's just do these two examples and you decide whether this is, the answer to this is infinite solutions or no solutions. Infinite solutions or no solutions. Remember, infinite is when it is truly equal. No solution is when it is false or not equal. Good? Pause the video and try it without me. Okay? So this is 3x minus 7 equals 3 times x plus 1. I'm going to start with distributing that 3. 3x minus 7 equals 3 times x is 3x. 3 times 1 is 3. Good? Oh, what does it look like already? True or false? You can move the x's or you can move the whole numbers, whatever you want to do. I'll move this 7 over because 7 is the bigger number, so I want it to be positive. I want the bigger number to stay positive. Those cancel. I'm left with a 3x. And I have a 3x over here. 3 and 7 is 10. Don't multiply them, add them. Good. Now I need x alone. All of my numbers are over here, so I need this variable to be over here. Okay, you have to move the 3x. It's a positive 3x, so I'm going to subtract 3x from it. Do that same thing to the other side, and I have 10 equals 3x minus 3x is 0. 0 equals 10. This is false, so this is no solution. Good? All right, so you might be able to guess what side this is. What happens over here? 5x minus 5, nothing to simplify, nothing to combine, nothing to distribute. I'm going to distribute the 2. 2 times x becomes 2x. 2 times 1 becomes 2. Plus 3x minus 7. You do want to distribute that 2 before you start combining like terms. So don't add x and 3x before you multiply out that 2, okay? Combine the 2x and the 3x because those are like terms, and then combine the 2 and the negative 7 because those are like terms. So 5x minus 5 remains the same. The 2x combined with the positive 3x becomes 5x. The 2 and the negative 7, so 7 and 2, they have different signs, so we're subtracting them. 7 minus 2 is 5, but the 7 is the bigger number, the bigger absolute value, and it's negative, so it's going to be 5x minus 5, which is an excellent sign, right? 5x minus 5 equals 5x minus 5. I'll add 5 to get rid of those, and I just get 5x equals, oh, it disappeared on that side too. Now I'm going to divide by 5 if I want to, or you can just tell, right? 5x divided by 5 is just x. 5x divided by 5 is just x. Good. So these are infinite solutions. All right, that is the end of 2.1, and I will see you next time. Thank you so much.